Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on EMC consideration. For this video, I'm going to concentrate on conductor emission. This video, I'm going to discuss step by step the test procedure of conductor emission. So this will be the objective of this video. This will be the part 56 series discussion on EMC. So guys, if you're keen to know more about EMC, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on EMC. This is my email. If you have any question regards on this discussion, please drop me an email. Okay, before I continue, I like to urge you guys to help me a little bit, okay, by like this video so that this video can reach a larger audience. If you guys are new to this channel, please consider to subscribe to this channel, or maybe later on you learn something from this video. Again, guys, help this channel by subscribe to this channel. Last but not least, please also turn on your notification bell in order to receive more information from this channel. Guys, I really appreciate your strong support. Thank you so much. Okay, so let's quickly understand what is conductor emission testing. Okay, when electromagnetic energy, somehow they actually get coupled into an electrical or electronic device, okay, maybe through the power cable or in fact any other cable, they are simply considered conductor emission. Okay, conductor emission can be happen either common mode interference or differential mode interference. Okay, let's go into differential mode interference first. Okay, differential mode interference is actually in between the live wire and neutral wire, or maybe in between the signal wire. Okay, which means that they don't actually exist on the wire itself. It actually happens in between, for example, a live wire or a neutral wire, which I'm going to illustrate a little bit more on the next slides. Okay, differential mode interference mainly happen, okay, from low frequency switching, okay, which means that, for example, you turn a logic on and off, okay, they actually happen pretty slow, and you can say that they have a low frequency switching, and that's where you actually have this differential mode interference. Let's go into common mode interference. Okay, common mode interference actually appeared in a live wire. Okay, for example, common mode interference actually appeared physically onto a particular wire. For example, a live wire, or maybe a neutral wire, or any other signal wire. Okay, basically with respect to earth connection. Okay, so basically this is a simple definition about common mode interference. Okay, common mode conductor emission often affects signal and control line. Okay, like what I mentioned earlier on, it actually happened onto a physical wire. Okay, for example, okay, you have this input and output line. Okay, basically somehow the signal integrity actually so-called degrade, and also the control, you actually somehow have some degradation in terms of performance, and basically this is what we call common mode interference. Okay, common mode interference is normally associated with high frequency switching, okay, which means that you turn on and off rapidly. Okay, nowadays we have a lot of transistors that turn on and off at a high frequency, and therefore common mode interference become a norm when we actually want to curb this problem in order to pass the conductor emission testing. Okay, so let's go a little bit understanding the difference between differential mode noise and also common mode noise. Okay, as for differential mode noise, is a mode in which a noise current flow on the same path as the power supply current. As you can see that this is how the power supply current flow. Okay, you can see that for differential mode, okay, the noise actually follow the same path as the power supply. So this is what it means. The noise voltage occur across the power supply line. So therefore, for example, let's say this is a live wire. Okay, basically all the noise appeared, okay, across the whole live so-called cables here. So basically this is differential mode. Okay, in differential mode noise, okay, the noise source appear across the power supply. And in short, you can imagine that they are actually in series with the power supply line. And the noise current actually, like what I mentioned, they actually flow in the same direction. Okay, it is called differential mode, okay, because you can see from here the outgoing and the returning current. Okay, this is the outgoing and this is the returning current. They are so-called opposite direction, and therefore that's why they have this name called differential mode noise or differential mode interference. Okay, let's move on to common mode noise. Okay, the noise voltage does not occur across power supply line. Okay, so like I mentioned earlier on, differential mode, they actually appear across, but for common mode, they don't appear across the power lines. The noise voltage occur across power supply line and reference ground. Okay, so basically you can see here, the key difference is basically they take a reference to the ground. Okay, the noise current flow in the same direction on the power supply, positive and negative side. Okay, so let's understand a little bit more. Okay, for common mode noise, basically there are noise in which the noise current, okay, somehow they actually leak through a stray capacitor, as you can see here. So somehow this is basically for a common mode. You can see that they somehow leak through a stray capacitor, okay, and they are like passing through the ground and return to the power supply line, as you can see here. Okay, it is called common mode noise because the direction of the noise current on the positive and the negative side of the power supply, they have the same direction. Okay, as you can see here, they have the same direction, and the noise voltage does not appear across the power line. Okay, you can see that there is no noise appear on the power line, but you can see that they basically leak through the stray capacitor, and that's where we have this common mode noise. So this is basically a very simple idea, the difference between differential mode noise and also common mode noise. Okay, like I mentioned earlier on this video, I mainly want to concentrate on the test procedure of the conductor emission testing. Okay, so let's move on. Okay, before I go into the test procedure, okay, I like to highlight that for conductor emission, okay, we actually has two types of standard. Okay, one will be the CISPR, okay, which is mainly used by the Europe, and then we have this FCC, okay, which is mainly used by US or United States. Okay, so what will be the key difference? Okay, the most notable difference will be the frequency range that is regulated for conductor emission. Okay, while both of them has the maximum frequency of 30 megahertz. On my previous video, I have mentioned that why conductor emission has a maximum frequency of 30 megahertz. Okay, but for this CISPR 22, for example, okay, the regulation actually extend down all the way to 150 kilohertz. Okay, while for SEC regulation, okay, they are actually start for 450 kilohertz. So in short, okay, the CISPR standard is actually much more stringent. Okay, because they start from 150 kilohertz all the way to 30 megahertz. As for FCC, okay, they actually extend from 450 kilohertz all the way to 30 megahertz. So you can see that for Europe, they actually has an extra 150 to 450. So basically, therefore, CISPR standard, they are actually more stringent. Okay, beside the frequency range that is different between CISPR and FCC, I like to also bring up three distinct, okay, difference between CISPR and FCC based on a setup. Okay, firstly, okay, you can see from here, okay, basically this is a ground plane. Okay, you can see that the gap, okay, from your EUT to the ground plane or vertical ground plane, okay, for CISPR, the gap need to be 0.4 meter. As for FCC, the gap need to be 1 meter. So this is the first distinct difference between CISPR and FCC. The gap in between the EUT versus the vertical ground plane. Okay, for CISPR, simply just 0.4 meter, but for FCC, it need to be 1 meter. So this is the first difference between CISPR and also FCC. So another difference will be the ground plane. Okay, for the ground plane, for the CISPR, you just need a 2x2. While for SCC, you need a 2.5 times 3. Okay, so this will be minimum. Okay, minimum for CISPR need to be 2x2. So therefore, if your ground plane, okay, you ensure that the size will be at least 2.5 times 3, then you actually meet the requirement from SCC and also CISPR. Okay, so this is another difference between CISPR and SCC, basically the size of the ground plane. And then the last one, the key difference between CISPR and SCC is basically if you have any access cable, okay, for SCC, you just need to bundle them together. Okay, but for CISPR, okay, anything that is accessed, okay, they need to be lesser than 0.4 meter. So this will be the key difference between CISPR and SCC. Firstly, the frequency range. As you can see that CISPR will be much more stringent because the frequency start from 150, while SCC start from 450. Second difference is between the gap of EUT versus the vertical ground plane. Okay, for CISPR will be 0.4 meter, for FCC will be 1 meter. Next difference will be the ground plane size. Okay, for CISPR is smaller, which is 2.2, but for SCC will be 2.5 multiplied by 3. And then the last but not least, any excessive cable. Okay, for FCC, you just need to bundle them together, but for CISPR, they don't allow any excessive cable more than 0.4 meter. So this is actually the key highlight, the difference between CISPR versus FCC, different on conductor emission testing. Okay, so let me move on to step-by-step test procedure of conductor emission testing. Okay, before I continue, okay, so I like to emphasize the three things here. Okay, first will be we call the LISTEN, okay, which is the line impedance stabilization network. Okay, LISTEN. Okay, maybe on the next video I will describe what is actually a LISTEN. But at this moment, okay, you can imagine that LISTEN is just a equipment, okay, that actually supply the power supply to the EUT. That's what you need to know currently. As I mentioned earlier on, maybe the next video I will do a detailed discussion on LISTEN. Okay, on the other end of the LISTEN, you can see that they are actually connected either to the spectrum analyzer or EMI receiver. And the task is simply to measure the noise. Okay. And then we have this ground plane. Okay, you can see that this ground plane, the horizontal ground plane and the vertical ground plane. Okay, so whatever component here, you can see that your EUT, spectrum analyzer, and LISTEN, basically they are all so-called connected to a common ground plane. Okay, so basically all the ground plane, they are all connected together. So therefore, this is just a very typical setup for conductor emission. And let me go through in deep detail on the conductor emission testing. Okay, first part, we go to the preparation. Okay, so we need to set up the test environment in a shielded chamber or room to minimize external interference. Okay, for example, this kind of setup, you don't really need to go into a chamber, for example. However, it is strongly recommended to go into a chamber so that any external interference will be minimized. So this is what it means. So the key thing is to set up this test environment. Hopefully you have this shield room or shield chamber so that you can actually minimize the external interference. Okay, so next you need to ensure, as I mentioned earlier on, the different test setup, okay, for example, SCC Part 15 or CISPR 22 standard. So basically you must be able to know the key difference between these two, which I have illustrated earlier on. So basically this is the first part, which is on the preparation on the conductor emission testing. Let's go to the second part, okay, which is on the setup. Okay, first you put your EUT, okay, is placed on a non-conductive table of height approximate 80 cm with ground plane on the bottom and behind of EUT. Okay, so you need to put your EUT onto a non-conductive table. Okay, the table is about 80 cm. Okay, so it need to be placed onto a horizontal ground plane. Okay, you also need to ensure that you actually have this vertical ground plane here. Okay, a LISTEN is connected to the 230 volt mains for providing the power source for EUT. Okay, so this is a listen. Okay, basically you have a filtered power supply. Okay, basically will be connected to the listen. Okay, in fact, for listen, you actually have two types of power supply. One power supply is simply to power up your listen. Another power supply, which is the filtered power supply, is to power up your EUT. Okay, like what I mentioned earlier on, I will describe more on the listen, hopefully on the next video. But at this moment, okay, you can imagine that this listen is basically connected to the 230 volt mains for providing the power source for EUT. Okay, and then on the other side of a listen, okay, basically will be connected either to a EMI receiver or a spectrum analyzer. Basically, their purpose is to so-called measure the conductor emission from the EUT, which I will illustrate later on. So basically, this is a simple setup. First setup, okay, make sure your EUT on a non-conductive table about 80 cm. Okay, and then next, okay, you need to power up your listen. Okay, I didn't draw here, but you can imagine that there are actually two power supply. One power supply is to turn on the listen. Another power supply will be the filtered power supply that is actually used to power on your EUT. Okay, so basically this is the second step on the conductor emission testing. On the setup, okay, let's move on to the third, okay, which is the measurement configuration. Okay, you need to configure the spectrum analyzer setting. For example, you need to include the frequency range, resolution bandwidth, and sweep time, okay, according to the test standard. Okay, nowadays I would say that for mine, maybe I should say that the test is actually automate. Okay, so basically I don't need to configure the spectrum analyzer testing, or like for example, I need to configure what are the range that they actually want to measure, what will be the resolution bandwidth, what will be the sweep time, etc. Okay, but I made this complete. Okay, so if you need, please do this. But if let's say all the test is automate, you probably can skip this part here. Next, okay, when you actually do a detailed scan, okay, make sure that you select the appropriate measurement mode. Okay, so we have this peak, quasi peak, and also average. Okay, so basically we have these three types of measuring mode, okay, based on different standard or specific test condition. Okay, so basically you need to set these three. Okay, but again, like what I mentioned earlier on, nowadays, okay, almost everything is automate. So basically for this measurement configuration, to be honest, I just press a button in a computer, it will be execute as per normal. But like what I mentioned, I just want to make this discussion complete, just in case that for some, your test and measurement on the conductor emission is still not automate. So basically this is on the third part, which is on the measurement configuration. Okay, let's move on to the fourth part. Okay, so basically we are ready to do the emission measurement. Okay, so we need to apply power to the DUT or EUT. Okay, and then you need to activate it as per manufacturer instruction. Okay, so various EUT, they basically have different instruction. Okay, for example, some EUT they turn on and off. Okay, for example, a smart device typically they will not be on 24/7. They will be on and off. So basically, you need to activate it as per what the manufacturer instruction mentioned. Next, use the spectrum analyzer to measure the conductor emission from the EUT or DUT. So basically, all the result will be captured by the spectrum analyzer or maybe EMI receiver. Okay, so sweep through the specific frequency range. Okay, earlier on, I have mentioned about the two frequency range from CISPR and FCC. Okay, make sure you sweep through all the frequency range and then you record the emission level at various frequency. Okay, like what I mentioned, typically nowadays, all these measurements, they are all automate. Okay, but in case for some, okay, so I describe what you need to do in order to make this conductor emission testing, okay, so-called complete. The conductor emission from the EUT, okay, basically they are in dB microvolt per meter. They are all captured by the EMI receiver, okay, on the final or maybe on the spectrum analyzer at the frequency. For example, this is from the CISPR, which is from 150 kilohertz to 30 megahertz. If for FCC will be 450 kilohertz to 30 megahertz. So depend on the different test standard that you want to measure. Okay, repeat the measurement for different operation mode. Okay, so some are standby mode, etc. So this is what I mean. It can be standby mode, it can be normal operation, and it can also be maximum mode. So do all this, okay, and then repeat all the conductor emission tests in order to complete the full test. Next, okay, so again, before I continue, if you learn from this video, okay, please like this video so that it can reach a larger audience. If you have not subscribed to this channel, please consider to subscribe to this channel. Thanks, guys. Let's move on to step number 5. Okay, we do in terms of the data analytics. Okay, we analyze the measurement emission data, okay, to determine if they compliant with the regulation limit line. Okay, typically you have this limit line. So as I mentioned, basically nowadays it's almost all automate. Okay, I actually select the limit line, and then they basically will compare whether they compliant to the limit line. If they are not compliant, they will do a detailed scan. Okay, so next, compare the measured emission level with the allowable limits for each frequency band and emission type. Okay, for example, conductor emission. Okay, you can do all these tests maybe for power line, for conductor emission, etc. on the signal line, which I have illustrated earlier on. Okay, in fact, conductor emission, we have this common mode interference or differential mode interference. So to ensure the test is complete, okay, you probably need to switch so-called the spectrum analyzer and also the EMI receiver to measure at the different cable, for example. Okay, so basically this is what in terms of step number 5, we do some data analytics here. For example, the measured emission is compared to the limit lines of CISPR 22. Okay, if the measured emission is less than the limit line of CISPR 22, okay, your EUT has passed the conductor emission test. However, if there is any point that exceed or non-compliant with the standard, okay, you need to identify the frequency range, okay, and then what kind of operation condition that this become a problematic. Then you can so-called tackle the issue later on. And let's come to the step number 6 for reporting purpose. Okay, so after you have successfully passed all the tests, you need to prepare a detailed test report. Okay, document all the test setup. For example, normally I will take a photograph, okay, to show the setup. So basically, I will do a photograph to show the test setup. I will definitely keep a measurement result. Okay, and do some form of analytics, and then do a conclusion whether your EUT can pass the test or not. So basically, this is what in terms of reporting. Okay, you need to include information. Okay, for example, your EUT or DUT, what are the spec, what are the test condition, what are the measurement setup, the measurement data, etc. Okay, and then if let's say if you any test, you must be also to provide some recommendation or how can we actually mitigate any so-called outstanding emission issue at respective frequency. Okay, for example, we can resolve this by adding filtering. Okay, for example, low pass filter or high pass filter. It depends on the situation. Okay, or we even need to reroute the whole so-called PCB board in order to pass the conductor emission test. Okay, so with this, I'd like to end my discussion. I hope with this you have a better idea how can you actually do a conductor emission testing. So with this, thank you so much. I hope to see you guys soon. Bye for now. Thank you so much.